In this video, we will talk about ideal and real voltage sources as well as ideal and real current sources. First, let's take a look at what ideal voltage source mean. An ideal voltage source is one that maintains a constant terminal voltage no matter how much current is drawn from it. For example, let's say that you have an ideal 10 volt voltage source. That voltage source will maintain 10 volt across its terminal no matter how much resistance you add with it. That means for 1 mega ohm resistance, terminal voltage will be 10 volt, and for 1 ohm resistance, terminal voltage will be same 10 volt. Also, it should be noted that ideal voltage source has zero internal resistance. However, in the real life, there is no such thing as ideal voltage source. The real voltage source has internal resistance that acts in series with the source. So, when current is sufficiently large, the internal resistance causes the terminal voltage to drop. When internal resistance is close to zero, the real voltage source acts like an ideal voltage source. In fact, for many situations, it is convenient to assume a real voltage source like an ideal one. Now, let's see the difference between ideal and real current source. An ideal current source, which is also known as constant current source, will supply the same current to any resistance connected to its terminal. That means whether you add 10 ohm or 100 ohm, current will be always same. This symbol is used to represent ideal or constant current source. The arrow shows the directions of the conventional current produced by the source. Since V equals to IR and here current is constant, the value of voltage will be changed if we change the resistance. There is no such thing as ideal current source. It is because a real current source always has some internal resistance that causes current to drop if the voltage developed across the terminals becomes sufficiently large. The real current source has internal resistance that acts in parallel with the source. This resistance, also known as shunt resistance. The larger the value of this shunt resistance, the more closely the current source approaches to the ideal one. When you need to convert the real current source to the real voltage source, you need to add this shunt resistance in series with the voltage source. The value of the voltage would be current multiplied by shunt resistance. Please like and share this video and subscribe to my channel. Thanks for watching this video.